Hello, welcome again to MSCI 541-720. Today we're going to talk about how a search engine is not the same thing as a database. They have some similarities, but they're not the same thing, and they differentiate based upon how we end up measuring whether they're working or not is probably one of the biggest things. But nevertheless, we're going to talk about that. And then we're going to talk about that Chapter 9 information representation that I distributed the last time, and then it's up and learn. This is really sort of talking a bit about pre-computer information retrieval, but in doing so, we cover a lot of some of the key concepts that we need to start learning. All right, so let's get into this now. All right, so we left off with this notion about what is sort of the purpose of a search engine. And I think this is good always to remind ourselves. All right, so search engines help people better satisfy their information needs. All right. And again, one of the big things here was it's all about people and it's their information needs. And so all suddenly the notion of quality is dependent upon who's doing the querying. For the same query, even different quality of stuff. So with that in mind, let's talk about a little bit about databases now. So I want to be really clear about this, that in the broad strokes of things, a search engine is not a database. Now, we might see someday the two fields come together. We might very well see databases as a ubiquitous tool that stores data for us and has all sorts of different ways for us to query and obtain the results. We could certainly see some of the functionality today that we call a search engine to be embedded in what we call databases now. But in general, these two things are very different purposes. Okay. Now, I want to note that at the query level, the distinction between the two can be a bit blurry. And what do I mean by this? Well, pretty simply, with a search engine, our notion of querying, this may or may not involve an explicit query and that query, so we could have an implicit query, and that query may or may not be a formal query language or be from a formal query language. All right, so let's talk about this a little bit. What do I mean by, so may or may not involve an explicit query? Well, I think it's easiest to explain that in terms of what do I mean by an implicit? So an explicit one you can think of pretty clearly as I go and I type in a query and I hit search into the search engine. That's an explicit query. And an implicit query could very well be something along the lines. So for example, you maybe have some link or a button next to a document that says more like this. So you found some document, you think it's a pretty good representation of the type of things that you're looking for, and so you tell the search engine, I want more things like this one. So that's an implicit query. The query basically turns out to be the document, but the user doesn't think of it as, oh, I'm putting it in a query. There's certainly not a query language. There's an implicit query there. All right. What do we mean by these formal query languages? So coming from databases, we know we have structured query language, this SQL or SQL, and it's very much, this has a syntax in the way we form things, and so that's what we mean by formal query languages, and they exist for search engines as well. So formal query languages, I would say they were more prevalent in the past. Certainly, all of the early pre-search engine, internet search engines that I ever had to deal with, how do you use them? We would often have a Boolean query language or something along those lines that you needed to learn how to structure and form to write the query for the engine or the tool that you were using. But as you're well aware of, most search takes what we might call natural language. So let people just type what they want to describe their information need or what they're looking for. Now, certainly, we can have the notion that, even when you're using Google, you can go into an advanced search mode, which is basically a special interface to be able to put in different parameters with regard to the search to basically use more of a formal query language with the search engine. But by large, the default thing with our modern web search engines is we just type some description of what we want or what we're looking for and so forth and so on. And it's up to the search engine to take and deal with that. And that is very much not like a database. These implicit queries, you might envision that you build an application that sits upon a database and users might do things that thus, the user never enters in the query language. And so maybe you could claim that there are implicit queries to the database in an application like that. So fine, but we certainly don't just type stuff, natural language to databases and expect to get good stuff back. Now, there's certainly been research on how users can do natural language queries with a database, but that's not our way of interacting with them at all. Whereas it is most definitely our way of interacting with search engines. So again, a database does have the formal query language with SQL. Now, at the results level, though, there are big differences between our two worlds. So at the results, so after you issue the query, we have big differences between the two. So let's say we've got a database. We're going to talk about it over here. We're going to talk about our search engine as well. All right, so we issue a query to a database, and we're going to get back, it's going to run over the tables, do joins, all sorts of great stuff. We're going to get a set of rows back. Is the database does it give us a correct result? Well, it's always correct. So we always get correct results. There's no notion of an incorrect result. So we always get correct results. Basically, we have 100% user satisfaction. I type a query, you execute it, you do what I told you to do, I am happy with you, I'm satisfied. And this is basically as long as the database is bug-free. And in all of our discussions of databases, search engines, we will always assume that we're dealing with a bug-free. In other words, we haven't implemented it wrong. It's not a issue of us, weird programming errors, logic errors. Never are we concerned about that. Let's assume that we have things bug-free. So if that's the case, we always get something back exactly. If you wanted to, for example, you could be issuing a query to it, which is, select star from, let's say we have a table called users, and they have a name, and we want all the names that start with M. So we issue that SQL query. It runs against the table. It checks for words that start with the letter M, and it returns us the rows that match. It does what, as long, this is syntax free, as long, it's no logic errors. It's done. Everything that it returns is exactly right. It does what we told it to do. It's just doing direct matching. It's done. It's over. That's what we expected it to do. Okay. There's no notion here of better or worse results. The results are either correct or we have a bug in the system. There's no middle ground at all in this system. All right. It's either bug-free and does what we wanted, or we've got bugs in it. And again, we're not going to talk about and worry about bugs. And so databases, we are always super satisfied with them. That's it. And sure, faster is better, but that's true about any system. The faster it works for the same results, the better it is. Okay, now in contrast, a search engine, so again, we're envisioning the world that's bug-free. The user can be dissatisfied with the results. You've experienced this, I hope, at least a couple times in your life. You're looking for something, you put in your query, and you're not happy with the results. You thought the query could work for you, but that's not it's not finding what you're looking for. It's not finding the stuff that you think is relevant. It's not doing its job, okay? So again, whether the engine is correct or not, it depends entirely on the user. If the user looks at the results and says to us, oh, I like them, the engine did a good job. If the user looks at the results and goes, that's not what I was looking for, the engine did a bad job. And no, we're not talking about a case where the user is looking for how to fix their car and they type in the word, dog. And yeah, that's the user making a mistake. But the user is probably not dissatisfied that the search engine didn't read their mind and turn the word dog into how to fix my car. So again, we put in a query. Many of these queries might be ambiguous. We might not know what to give the person, and different people want different things. And we still, though, are going to try our very best to satisfy them with what we return. Okay. And in contrast to the database, where sure, yes, for both systems, faster is better, but we could have a trade-off. There could be a trade-off of speed versus quality. We don't usually deal with this. We talked about this last time, but it is certainly possible. We might be willing to sacrifice speed for improved quality. Again, the database either works or it doesn't work, and so the faster it works, the better. Here, maybe with some more computation, maybe we could find some results that satisfy us, help us solve our information need better if we spent more time with a more sophisticated algorithm. So there could be that possibility here with the search engine. And really, there is lots of work when dealing with search engines on the issue of how to measure quality and how are we going to actually improve these algorithms that decide on what is actually going to be returned. This is the whole crux of the problem. How can we actually compute and figure out what to actually give the user? So there's a huge amount of work in those algorithms. The work on the database side with algorithms is about how to do things faster, maybe more complex queries, so forth and so on. That, again, it's still just correct or it's not, but it's, as long as it's implemented correctly, it's always correct. Here, we can keep working and trying to be more and more, basically it's like making the algorithms be more and more like what maybe a human could do. So that if we were to describe to a human what we were interested in, the machine could be smart enough to understand and look at document after document and go, ah, yes, that's what you're looking for. I understand. This is all about, there's machine intelligence here doing, trying to mimic what humans can do. But at the same time, we have this really fascinating issue that what's the correct answer depends upon who the user is and what is it that they're currently looking for. And again, we can see the same input from different users wanting different things. And how can we deal with that? All right. So we have this problem in this course sometimes. Now, I will say almost all of you are like, all right, I buy it. I understand. Databases and search engines are not the same thing, and I get that. And you can think about their own experiences with using search engines and how, no, it's not just look up this word in these documents and find me all the documents that contain a string matching. So it's not like string matching like in SQL. It's this bigger problem. But we do have, I've run into in previous years some students who fight this all term long. So I'm just going to put it out here right now. Like, if you're going to tell me on the final exam that databases and search engines behave and they're the same thing, and you don't know why in the world you took this course, I mean, I'm just going to have to find a way to, like, I don't know, maybe fail you. I don't know, at least take some points off. It's very frustrating. There's a really big fundamental difference between the two there. All right. So now we've talked about databases versus search engines, which has given us a chance to review what is the purpose of a search engine. Now let's get into sort of pre-computer times. Let's talk about information retrieval before we had computers or before we used computers for information retrieval. Now, my entire life, we've had computers. They were invented before I was born. I'm not that old. But I've actually used non-computerized information retrieval systems. You might have as well. Depends upon your upbringing and where you're from. But let's think about this. I know it can be difficult, but let's think about life before the ubiquity of personal computers, smartphones, before we had internet connections, before we had websites and search engines. I mean, let's just go back. So imagine a time when no one has a computer in their household, and perhaps the most computerized thing they had was a calculator. Okay, so now you're in this era, and by the way, that era, my family got its first computer in the 1980s. So you don't have to go back too far. And by the way, that computer wasn't connected to any network. It was just a computing device, and we had software for it. And so the only way it changed was by running different software programs that we purchased for it. And that was about it. And so actually, unless you had a need to do something with it right and then and there, it was turned off. There was no notion of like, ooh, let me go to my computer. Let me go to my computer and do stuff the way we are now. I mean, our computer would sit off for days at a time, maybe even weeks for all I know. And we'd fire it up and type a paper up on it for using it as a word processor, as a fancy typewriter almost. All right. Anyways, so before that time, or before we were using computers, you have an information need. Envision this. What are you gonna do? How? Today it's it's so simple. Type it into your phone, speak it into your phone, speak it into your assistant, your Alexa, your Siri. Go to your web browser, quickly type in something, and you instantaneously get something back. It might not be what you're looking for, but a lot of the times it is. But no, that doesn't exist. There's no way to do that. It's almost like you could envision that maybe you have a power outage and your batteries are dead and everything. And what are you going to do? You need to find some information. So, well, you might have some books at home. So the sense of maybe you've got this is value of having books. For example, you'd have a dictionary, be able to look up how to spell words, look up how to what are the definitions of words. So you'd use your dictionary for that sort of thing, that information need. Maybe some facts and figures. So you might have an almanac. And so you'd be able to look up in an almanac, what is the population, and your figures would only be up to date, to a certain, the last 10 years or something. But what was the population of this country? And you'd go and you'd find and try to find that in that almanac. And you might be so lucky to have an encyclopedia. But encyclopedias were very expensive. They'd take up this amount of space on your bookshelf, lettered A through Z, and you'd open them up and you'd be able to. It was every elementary school child's thing. I'll write a report on Spain. Ooh, we have an encyclopedia. I don't have to. Oh, great! I can go to the encyclopedia, open up. And wow, there's this little article, maybe it's a couple pages, telling me all about Spain. Its people, its agriculture, its industries, its geography, its weather. Now, those are expensive. You were really lucky if you were able to have an encyclopedia at home. So you're like, don't have that much information actually available to you at home for a lot of stuff. I mean, some of those information needs you might satisfy. Maybe they're more current, and so you might turn to your newspaper. Newspaper is where you'd always turn to look to find the TV listings. And again, with only 4 channels, that wasn't a problem. Look up movie times. You'd go to the newspaper, and so forth and so on. So you might have some of those ones. You might ask someone. You might ask a parent, a sibling. You might call someone, call a friend. You might be able to do something like that. But and by the way, so if your information need was bigger than that, though, wow. All right, time to really get out the big guns and go to the library. This is the place where we've got lots of information. We as a community have pooled our resources to collect as a group of people a whole bunch of information for us to share. And we can go to the library and access that information. If you were a small library, small neighborhood library, you might have in a small neighborhood library, I would say, it would be a pretty nice collection, about 20,000 books. And sure, you'd have some magazines as well and some other stuff. But the big thing would be, the book collection. So but that's a small neighborhood library. This is the type that you can go into, and standing in one spot, you can pretty much see most of the books pretty easily. Now, then there would be larger communities that have larger libraries and so forth. And sort of the peak of libraries is the research library at a university. So if you were to go, for example, to the University of Waterloo's library, and it took me a while to try to find an estimate of this, and it still might be wrong, but the University of Waterloo, I believe, has approximately 2.3 million volumes, or we could say volumes is approximately what we mean by a book. And it also has it has access to a huge amount of journals and other resources as well. But primarily we're talking, these are probably the journals and the books and stuff, but 2.3 million. So there's a huge scale difference there between 20,000 and 2.3 million. Now, nevertheless, and so this is really where you would be able to go and start to find some information and hope to be able to satisfy that information need that you have. By the way, a lot of you are probably saying to yourself, I think for a lot of my information needs, I would just go, I guess I'm not going to know it. And that's a beautiful thing about the modern age, how quick we are able to obtain information and use it. And it just accelerates things so much in society. And I think it has a huge impact. And again, another reason I think search engines are such an incredible thing to study. So now these, by the way, this sort of thing here, these are easy to search. Okay. All of these, though, are, other than trying, it's not like you're going to, where certain types of information are in the newspaper. Otherwise, it's just stories to read. You're not going to have a gigantic past collection of newspapers at home to search through. Asking someone, of course, is easy as well. You just ask the question and they're intelligent and they either know it or they don't know the answer. Now, dictionaries, almanacs, encyclopedias, these are all designed as reference materials, and all of them contain in them some notion of what we would call an index. What's an index? Well, an index is a tool which when you look, it's like the index in the back of the book. Basically, the idea is they're organized in some way so that we can quickly find the item that we're interested in them without having to turn every single page and read every single page. I mean, the dictionary is in alphabetical order. That makes it a lot easier for us to find the word that we're trying to find. If we put them in random order, you'd have to read the doggone entire dictionary on average halfway through each time just to find it. Almanacs as well, nice index in them. Encyclopedias, their very nature again, they're just set up alphabetically so that you can look up. You look up Spain, you find Spain in the S volume, and it'll, you know, I don't know what comes before it or after it, but anyway, you're going to find it. So we use these indexes. They're these mechanisms that we can get to the information that we want to find. The index, you pick up like a cookbook or anything else, and you go to the back and you can search for ingredients and stuff, and then find the pages that have the things that you're looking for. These are ways for us to quickly find the piece of information that we're finding, that we need to find. So that's a key tool, and we'll come back to this idea of index over and over again in this course. But what about the library? How are you going to search a library? Pre-computer, that is. So you don't have the computer that you go right now onto the web page, and you can just type stuff in, and the University of Waterloo Library system behaves largely today like a search engine, and University of Waterloo will find things in magazines, journal articles, books, all sorts of stuff, all from one interface. It's quite an achievement. Now, back then though, pre-computer, what is it that we did? All right, so in the simplest sense, a really, really tiny little library. As the books were, and I mean by tiny library, I'm talking like a personal library, or maybe a church library or something along those lines, where they got 100 books or something. So as you buy them, you number them. Oh, this is my first book, number 1, and you stick it at the number 1 spot on the bookshelf. Buy another book, oh, it's book number 2. And as you also maintain a little list where you go, oh, book 1, and you write its title, who the author is, book 2 and stuff, and you've got a nice printed sheet. And, and if you need to find a book, you go, where was that book? And you go, da-da-da-da-da-da-da-da. Oh, yeah, it's book 23. And you go to the shelf and you scan, and you're like, there's book 23, and you pull it out and you're happy. And you're like, my information retrieval system for finding the book that I wanted worked quite well. But that's what we would call a known item search, by the way. You know what you're looking for by the title. It's something, it's a collection small. You expect it to be there. Alternatively, maybe if you didn't know the title, you'd still, for the really small collection, maybe there's only 100 books, you'd still just scan the titles until you found a title that you thought, oh, maybe that would contain what I want in it. And then you could go look, and you could open it up and decide whether it was relevant to you and your information need or not. So we're not talking about tiny little libraries. We're talking about at least the neighborhood library with 20,000 books. We're not going to have you browse 20,000 books trying to find what you're looking for. We're certainly not going to, when you have 2 million volumes, going to be like, have at it. Like, look through them all and maybe you'll find what you're looking for. That's not going to work. All right. So the invention to solve this was basically the invention of the card catalog. Okay, so a card catalog was the search engine of libraries. And what was it? Well, the basic idea is, and I'll use through this books. I'll keep talking about books. Certainly it could be other items that we're talking about, but let's just pretend we're always dealing with books here. Basically, for each book, we would create, or the library, I'll just say the library, would create, 3 or more cards that could help people find information to satisfy their needs, their information needs. So wait a minute, what about these cards? Well, these cards we're talking about, these are typical. This is old style, 3 inches by 5 inch card. It's not that big. It's 3 inches by 5 inches. Is a small little note card. Okay, and these cards. So again, we're going to make 3 or more cards that could help people find these. And so one thing you might say, well, someone coming into the library, they might know the title of the book, and they'd like to just find where in the library that book is. And so you would make a title card, and so you would write the title of the book, and then you would have other book info like the author, the number of pages, the publisher. It'd be all these details. And as well, you would put on here what's called a call number. The call number is your code to where to find the book in the library. Again, in the simplest sense, it would be like those numbered books in the tiny little library. But the call number is instead actually a scheme, usually a classification scheme, such that books of a certain type have similar numbers. Then we divide the library up based upon those numbers, and such that then we can order the books in that portion of the library by the call number. So there's a way to order it by the number still. And then you can go and you look and you say, oh, yeah, my books start, I've got a QA 76. These are like computer science books. I know, you looked them up so often. And so, yeah, where, you got a little map in the library, where are the QA books? Oh, there's the QA section. And then you go and you walk down the aisles and you look and you find, you know, where are the ones that from QA and start with 76, and then you walk down the aisle and you're going to look and you're going to find, you know, and so forth and so on until you're like, ah, there's the book. Or you're going to be like, it's not there. It's been checked out. Anyways, that's the way you use it. You just got this little card. It's got a title, book info, and it tells you where to go find it. Each one of these cards has a hole on the bottom of it. What's the idea behind the hole on the bottom? Well, these cards would be placed into large drawers, long and deep. So you'd have a drawer. A bunch of cards in your drawer. And on the front of it, you'd have a little note. And this may be, you know, these are titles AAA through AS or something. All right, so these are a whole bunch of books that start with the letter A. It's not even all of them. And then all of these would be put into gigantic cabinets. And we would have, you know, you've got drawer after drawer after drawer after drawer. Okay, and you've got like, you know, these are the A's and the B's and the C's or whatever. And so if you've got a title of a book that you know that you want, and you go, oh, the first letter in that book is this. And then you go and you find that drawer, you pull the drawer out, and these cards, they're actually all threaded on a rod in the drawer, and you flip through the cards in alphabetical order until you find, oh, there's the title of that book. And then you write down the call number on a piece of paper, and then you look in the map and you go find that doggone book. Each one of these cards, we can view it as a surrogate. It's a surrogate that allows us to, so that this is a lot more efficient to look at this sort of small representation of the actual book as opposed to having to scan through all the actual books. Because certainly someone could make a library where they, oh, let's put all the books in alphabetical order. And you could then go and you could scan and you could find that book in alphabetical order by its title. There are some problems with that as we acquire books. How do we shift all of them and insert them? So that's a bit of an issue, but it's the same issue if we order them otherwise. But in fact, what libraries, they don't put them in alphabetical order. Again, they use these call numbers, which is a classification scheme by their general topic area. And then the advantage of this is with this scheme, when you find the book that you're looking for, by the way, and you end up on the shelf, you'll find other similar books by topic when we're talking about nonfiction books, okay? So the nonfiction books will be grouped on a shelf by subject, and you can actually browse nearby books because they'll be related to them in some broad sense, subject-wise. Anyway, so this is what card catalogs were. And I said 3 or more cards. That's one card. That's one title card. What are all the other cards? Well, in addition to a title card, it makes sense to make an author card. I put the author's name by last name here, and again, the book information and the call number. All right, so we've got title and author. Some libraries could actually intermingle titles and authors, but in general, usually for large libraries, you separate them out. And so you've got title cards in one set, author cards in another set. And again, so this is 2 different ways to get at and find a book. One by looking up by author, one looking at title. This information retrieval, though, you're like, now Mark, this sure does seem a lot like a database to me. Absolutely, positively. That's like a database, okay? You know what you're looking for. These are what we call these known item searches. And you just need to find what matches there. But the third or more card that you would create would be, you would have some sort of subject here. Or we could say we could have some sort of index phrase. So the subject might be woodworking, okay? And then you would have some sort of title, author, other book info to describe this book, the publisher, the number of pages. You might even have a little written summary of what the book is about. And again, you're going to have the call number so that you can decide if you want to actually, if you decide looking at the surrogate representation of the book, whether you actually want to go to that book. Now, I keep talking about the surrogate information. This is just like, think about this as like when you put in a query into a search engine and you get back these results and they've got a title with a link that you can click on and it's got a little snippet. That is a surrogate for the actual document, the actual web page. You then make a decision about whether to click on that item, that surrogate, and actually go fetch and retrieve the web page that might have the information you're looking for. This is the same thing. This is like a little snippet, and you're going to decide, in this sense, it's a lot more expensive than clicking, but you're going to decide whether to write down the call number and go hoof it down the library to go find and see if that book is actually in stock or not. Not in stock, whether it's not been checked out or not, whether it's on the shelf. All right, so, wait a minute. So we're not in information retrieval course. We're not interested in looking up titles. We're not interested in looking up authors. We would call a title and an author meta information about the book. This is just details that we can just write down. It's very structured information. That's a database problem. What's interesting here is this issue about this choice of the subject, this index phrase. I said woodworking, okay, but maybe the book is about cabinet making. Maybe it's an introduction for children to building projects out of wood. How do we pick this and and so forth and so on. And this is what's going to lead us down into this discussion about where we're going with information retrieval. So one thing I wanted to point out, you might have noticed in Learn and in some of the other places, this brown picture with these, what looks to be sort of, I guess, looks like drawers. It's a picture of a card catalog. What card catalog is it? It's actually quite interesting. That is a picture of the card catalog at the Parliament building. It's the Parliament Library in Ottawa. So there's a library that is in the attached, it's part of Parliament, and it's there, it was there for the lawmakers, and it had card catalog, beautiful, all the carved wood and everything. The card catalog's currently empty. So that's why the picture doesn't have any labels on the drawers, because there's no cards in the card catalog anymore. Everything's been replaced with a computerized system to find books in the Parliament Library. All right. So